Help Josue Coco graph a piecewise defined function. Here we have f of x. First statement will state negative x. And we have intervals that say x is less than 0. For a second expression, we have x to the second power. Our intervals state 0 is less than or greater than x. X is less than greater than x. And for our last, we have y and x is greater. No, we have y equals 1 and x is greater than 1. We'll begin with negative x. Okay. When negative x equals negative 1, this signifies that y equals negative, open parenthesis, negative 1, which grants us a positive 1. Next, when x equals negative 2, y equals negative, negative 2, which grants us positive 2. Lastly, we'll state negative 3, x equals negative 3, y equals negative, negative 3, ultimately giving us a positive 3. Let's make some space here and move on to x squared. X squared, x to the second power. On the left side, we'll place our x values, and on the right side, we'll place our y values. Notice how the values will only be 0 and 1 here. When x equals 0, y equals 0 times 0 results in a product of 0. Next, when x equals 1, y equals 1 times 1, producing a 1. Let's make some space here and continue with our last statement here. Our last expression states when x is greater than 1, y will always be 1. So here, we'll say 1. Okay. We have here in x is greater than 1. We'll represent this in a table numerically. Here we go. X, y. Okay. So when x equals 2, y equals 1. When x equals 3, y equals 1. This statement here will be in a horizontal line. Okay, let's minimize this statement here. Next step, we'll graph our piecewise defined function, staying true to the set intervals. Okay, here's our y-axis, drawing our x-axis. Let's have a few values here, the origin. Here's our x-axis, our y-axis, and on the left side of our x-axis, we're going to have -3, -2, and -1. On our y-axis, we'll move upward 1, 2, 3, and on the right side of the origin, we have x going +1, 2, and 3. Okay, let's begin with -x. Let's begin when x equals -3. Y equals +3. So somewhere around here. We'll plot -2 next. When x is -2, y is +2. Lastly, when x equals -1, y equals +1. And that should land right about here. And the line will continue until it reaches the origin. Next, we'll take x squared. Now, x squared, we'll mark it in the origin. Here we go. When x equals 0, y equals 0. When x equals 1, y equals +1. Now, this is x squared. This will represent a curved line going upward. Finally, we'll take x is greater than 1. This will be a horizontal line. Let's make some space here and begin with x equals 2, y equals 1. Next, when x equals 3, y equals 1. Now that we've plotted our points true to our intervals and our statements within f of x, we'll begin to connect. We'll start here when x is greater than 1, y equals 1. A straight horizontal line from 1 to 3 in this example. We'll label this line y equals 1. Moving along, we have x squared. Granting us a nice curved line from 0 to positive 1. And this is x squared. Y equals x squared. Y equals x squared. X to the second power. Lastly, we'll take when y equals negative x. This will be a straight line, and we'll mark it as y equals negative x. Let's minimize our graph here and clearly state that the entire graph shows f of x. F of x. So y equals f of x.